This video is for Chemistry in the Earth System, Unit 3.5, Chemical Formulas. Today's essential question is, how are the formulas for molecular compounds written? Our first main idea, chemical symbols and subscripts. The ions in an ionic compound form a cluster of charged atoms or groups rather than a discrete molecule. Although attracted to one another, the ions are somewhat independent, but this is not the case in a molecular compound. Molecular compounds are also called covalent compounds. In covalent compounds, valence electrons are not gained or lost by the compound's atoms. Instead, in a covalent bond, a shared pair of electrons are shared between the two atoms. This is because the electronegativity difference between the nonmetals in the bonds are not great enough to cause a transfer of electrons and therefore results in sharing. This is the reason that these groups of atoms form discrete molecules rather than ordered clusters. Now, like the formulas for ionic compounds, the formulas for covalent compounds consist of chemical symbols and subscripts. A molecular formula describes the components of a molecule, including the number of atoms of each element that are present in one molecule of that compound. A molecular formula may describe a molecule of a single element. Now, for example, H2, which is the molecular formula for hydrogen gas. This means that in the gaseous state, hydrogen forms a molecule consisting of two covalently bonded atoms of hydrogen. Similarly, oxygen, with a molecular formula of O2, fluorine, F2, and chlorine, Cl2, do the same. Note that these differ from the chemical symbols for these elements because they contain subscripts. Elements that form diatomic molecules are referred to as diatomic elements. A molecular formula may also describe a molecule that contains atoms of two or more elements. For example, the molecular formula for the compound hydrogen chloride is HCl. The molecular formula for the gas methane is CH4. The molecular formula for a molecule of the sugar glucose is C6H12O6. In each case, the molecular formula describes the element, meaning the chemical symbols, and the quantity of the atoms, the subscripts, that make up a discrete molecule. Naming molecular compounds. Molecular formulas are a convenient way to describe the elements in a compound and the ratios of the ions or atoms present. The chemical name of a molecular compound often reveals the elements it contains. In some cases, the name may also describe the amounts of each element that is present. For example, the name hydrogen chloride, HCl, reveals that the molecule of this substance contains one atom of the elements hydrogen and chlorine. The name hydrogen bromide would reveal that a molecule of this substance contains the atoms of hydrogen and bromine. What, however, do the names carbon dioxide and carbon tetrachloride reveal about the components of these molecules? The answer to this question lies in the analysis of the words and word parts in each name. In the case of carbon dioxide, the names of the two elements are mentioned. These are carbon and oxygen. It is clear that carbon dioxide molecules are made up of atoms of carbon and oxygen. Additionally, the name reveals something more, a quantitative fact. The prefix di, means two. So the name carbon dioxide reveals that the molecule of this compound contains two oxygen atoms. This is shown in the molecular formula for carbon dioxide, CO2, which is shown on your screen here. What about carbon tetrachloride, which is also on the previous screen? What does its name reveal about the components of its molecule? A clue to the answer lies in the prefix tetra, which means four. Therefore, A molecule of carbon tetrachloride contains 4 chlorine atoms. The molecule's chemical formula is CCl4. Molecular compounds containing 3 or more elements have fairly complex rules. At this point, you should be able to generate a full and appropriate response to today's essential question. How are the formulas for molecular compounds written?